morning everybody. Hope that all of you are good at your home. Today we will discuss our chemistry first chapter, that is solid state. It is one of the most important chapter of chemistry because from this chapter during board exam also they used to ask the question as well as in different types of entrance, numerical as well as small question answer. So as the name suggests, the chapter name is the solid state. And we all know matter exists in three different states, that is solid, liquid and gas. Solid, liquid and gas. So what is solid? Solid is the substance where molecules are very closely packed. Closely packed, or they have least interparticle space. For example, we can take example of sodium, copper, zinc, etc. What is liquid? Liquid is the substance where they have some intermolecular space. Liquids, they have some intermolecular space. How they have intermolecular space? This can be proved. Take a glass of water, put a spoon of salt or a sugar, stir it nicely, then you will find that salt or sugar, it will completely soluble or dissolve. Then also the volume of water or the level of water will remain same. It will not increase, it will not decrease. In case of gas, we know these gas molecules are always in their random motion. Here and there they will move. And the gas molecules or the particles are situated far away from each other. For example, in case of gas, we can take oxygen, carbon dioxide, etc. In case of liquid, we can take example of water, benzene. Discuss about the types of solid. Types of solid. As earlier we have stated, what is solid? Solid is a substance where molecules are very closely packed. They have rigidity, high density, low compressibility. And another important characteristics of the solid is that solid have sharp melting point. That is, whole of the substance will melt at a specific temperature. Now we'll discuss about the types of solid. Solids are generally classified into two classes, namely crystalline solid and amorphous solid. Amorphous solid. What are the crystalline solid? These crystalline solids are those solids which have regular geometrical pattern throughout the crystal. That is, their geometrical pattern is repeated throughout the crystal. Over a very long range. In case of amorphous solid, they do not possess any order pattern. They may be zigzag way. Here and there they will be. In case of crystalline solid, they are also called anisotropic in nature. And this is, in case of amorphous, they are also called isotropic. In case of crystalline solid, as we know, they have regular geometrical pattern over a very long range. They are also called anisotropic in nature. That is, they have different types of physical properties in different direction. For what are the different types of the physical property? They will have different value in different direction. These are the refractive index and conductivity. Why they have different in different types in different direction? Because if we move from this side, we'll get a arrangement 1, and if we'll have move in this direction, they will have another type of arrangement. Take for example, this is a crystalline solid, positive, negative, sorry, crystalline not ionic, positive, negative, positive, negative, positive, negative, positive, negative, positive, positive, negative, positive, negative. Then we'll find that in this direction and from this direction and this direction, they will differ in their refractive index as well as their conductivity. That's why they are called anisotropic crystals also, and this is one of the most important characteristics for crystalline solid. But in case of amorphous solid, as they do not have any regular geometrical pattern, if you will go from any direction, you will find a same types of arrangement. It looks almost same. That's why they will have same value of their refractive index as well as conductivity. Some examples of crystalline solids. For example, NaCl, KCl, ZnS. And in case of amorphous solid, glass, rubber, etc. And another important thing, these amorphous solids are also generally sometimes called as a supercooled liquid or pseudo solid. Why they are called also pseudo solid? They are called, take for example, glass. For a very old building, you will find that the upper portion of the glass become thin and lower portion of the glass become thicker. That means what? Due to their weight, they used to be flow towards gravity. And another example of amorphous solid, these are also another examples of amorphous solid, that is glass, pitch. These are also called pseudo solids. Now we'll discuss about the difference between crystalline solid and amorphous solid. And this is one of the important difference. During exam also it used to ask difference between crystalline solid and amorphous solid. So as already we have defined that what are the crystalline solid, they have definite regular arrangement of particles. Over a very long range. So for difference, we'll just writing the important points one. Next they are true solid. Next one, they are anisotropic in nature. Earlier we have already discussed what is anisotropic. Anisotropic means what? As in case of crystalline solid, they have regular arrangement of atom. So if we go for different direction, in different direction it will show different types of physical properties. For example, refractive index, conductivity, etc. And another important characteristic of crystalline solid, they have sharp melting point. That is, at a particular temperature, whole of the crystalline solid used to be melt. Next one is the amorphous solid. What is amorphous solids? Earlier we have already discussed. Now we'll see the differences between crystalline and amorphous. They do not have regular arrangement of atoms or particles throughout the crystal. Next, they are also called supercooled liquid, or they are also called pseudo solid. They are isotropic in nature. As earlier we have stated that in case of amorphous solid, they do not have any regular geometrical pattern, that is, the particles are randomly distributed. So they, for different direction, will find in same types of their physical properties. For example, refractive index, conductivity, etc. And next one, they do not have any sharp melting point. That is, whole of the substance will melt certain range of temperature. For example, suppose a substance used to be melted around 70 degree to suppose 75 degree Celsius with a certain range. This is for example. Alright. Earlier we have discussed about the different types of solid, that is crystalline solid and amorphous solid. Today we will discuss about the classification of crystalline solid. Crystalline solids are broadly classified into 4 classes. We will discuss about each classes separately, about their crystal type, what are the constituent particles, binding forces, properties and some example. Alright, so first one is the molecular solid. What are the constituent particles for molecular solid? As the name suggests, in molecular solid, small molecules. Molecules or same types of atoms are present as a constituent particle. Now, what is the binding force in between them? In molecular solid, the binding force is the weak van der Waals force. Waals force. And in some molecules, H bonding is also present, that is hydrogen bonding, as well as dipole interaction. Next is the property. Molecular solid, small molecules or atoms, and weak van der Waals force. So their properties also be, they are very soft, because weak force of attraction between the particles, so they are soft. They have low melting point and low conductivity. Or sometimes most of them are act as an insulator. Some examples are solid, CO2, iodine, P4, acid molecules. Next one is the most important one. That one is the ionic solid. As the name indicates, that these are the ionic solid. So what will be their constituent particle? This solid we have studied so many times. They are generally positive ion and negative ion. That is what? They are cations and anions. They are negative ion and positive ion. So what is the binding force between them? In this ionic solid, the binding force is the strong electrostatic force of attraction. In ionic solid, the binding force is the strong electrostatic force of attraction. As now their properties. As they are in ionic solid, the force of attraction between them is strong electrostatic force of attraction. So they are very hard, brittle, and they are good conductor, or they conduct electricity in molten state. Always remember, in case of ionic solid, they are bad conductor in solid state, but they are good conductor of electricity in molten state or in solution, and they have high melting point. Some example: NaCl, KCl, ZnS, etc. Already we have discussed two types of crystalline solid, that is molecular solid and ionic solid. Now we will discuss about the covalent solid. Covalent solid. So as the name suggests, in case of covalent solid, the constituent particles are generally non-metals, and the binding force between them, as they are covalent solid, the binding force is the covalent bond between them. In case of covalent solid, the constituent particles are generally non-metals. Covalent bond, their properties, they are very hard, high melting point. Because why they are in case of covalent solid, they have covalent bond, they are hard and high melting point. If we take the example, we will get clear. That is diamond, graphite, and silicon carbide. These are the some examples of covalent solid. Last one is the metallic solid. Metallic solid. In case of metallic solid, the constituent particles are generally positive ions. Positive ions. Positive ions. Generally, these positive ions is surrounded by the electrons in metals, and the bond between them is the metallic bond. Metallic bond between them is present. This metallic bond is generally the electron and the kernel. Their properties, they have variable hardness and very good conductor. One of the interesting thing in case of metallic solid are the very good conductors of electricity. But remember, in case of covalent solid, they are the least conductor. Some exceptions are there. Then also in case of metallic solid, they are very good conductor, always remember, and covalent solids are least conductor. So some examples of metallic solid are copper, silver, gold, etc. Alright, these are the 4 different types of crystalline solid. Today we have discussed it out. Alright, thank you everybody.